Hello everybody, my dear mathematics section students. This section is about some method of integration. This section introduced in the period of coronavirus spread. God save you and save our dear country. Firstly, the first type of method is integration by parts. We should know some remarks to help us to solve some different examples. Firstly, we should know the rule of integration by parts. Integration by parts depend on we have two functions. Then the basic rules is integration u dv equal uv minus integration v du. And we can use the symbol I to represent the left hand side of the rule, integration u dv. Then the basic rule of integration by parts is I equal uv minus integration v du. Save this rule in your mind. We will use it to solve some different examples. Second, before using integration by parts, we should do a simple test. We have three cases. The first case is integration for function by exponential function f of x e power g of x. The first key is if the derivative of the power g of x is the function f of x. That means that the derivative of the power is beside the function e power gx. We use chapter 1 that integration will be the same function e power g of x plus constant, except that we use integration by parts. Let we have some examples about this point. Evaluate the following integration. Sin x times e power 1 plus sin x dx. We use the first key, g by dx, for the function 1 plus sin x equal sin x. The function beside e is the derivative of its power. Then we use chapter 1, it's the same function plus constant, not integration by parts. Example 2, integration x e power x cube dx. We use the first key, g by dx for x cube equals 3x squared, not equal x. So we should use integration by parts as the first key doesn't work here. Second case, in case of product of two functions, one of them is trigonometric function as follow. Then we have the second key. The second key is if the derivative of the angle gx is the function f of x. That means that the function besides the trigonometric functions is the derivative of its angle. We use chapter 1 to solve it, as its direct integration, as sine equal negative cosine by integration and cosine equal sine by integration, except that we use integration by parts. For example, integration cosine x sec squared sine x, then the angle is sine x, and d by dx for sine x is cosine x. So it's direct integration. Sec squared integration for sec squared is tan x plus constant. Evaluate the following integration. The second integration, x sec squared x cube. We use the second k, or do a simple test. G by gx for x cube is 3x squared, not equal x. Then the second key doesn't work. we must use integration by parts. The third key is about if we have product of brackets with power n and another function as follow. The third key, if the derivative of the function inside the brackets gx is the function gx. So we use chapter 1 with adding 1 to the power and divided it by the new power. That's the rule. But note that n not equal negative 1. Except that we use integration by parts. Example 5. Integration for 2x times x squared plus 1 power 5. We will find d by dx for x squared plus 1 equal to x. Then it's direct integration. So the result will be x squared plus 1 power 6 over 6 plus constant. Example 6. Integration x times x brackets x plus 1 power 5, where d by dx for x plus 1 equal 1 not equal x. So the third key doesn't work. We must use integration by parts. 3. If the integration contains inverse of trigonometric functions or ln x, then we must use integration by parts. We must use integration by parts. As sec minus 1 or ln x, we must use integration by parts. 4. How we can choose u and choose dv. Choosing u, if we choose u by x, then du is dx. Choose u by e power x, then du e power x dx. If we choose u by ln x, then du equal dx over x. If we choose u by tan, then du equal sec squared x dx. And the inverse of trigonometric functions. Notice that all inverse of trigonometric functions, we put it in u. On another hand, choosing dv, we can choose dv by dx, then v equal x. Choosing dv x dx, then v x squared over 2. Choosing dv by e power x dx, then v equal e power x. And sine x, cosine x, sec squared x. We note that ln x must be in u, and e power x and x may be in u or in dv. So number 5, if we have integration contains of x and e power x, which you can put it in u or put it in dv. So the correct choose is putting x in u and dv e power x dx. Second, integration x ln x. Ln x must be in u, then dx equal dv equal x dx. If the integration in the form e power x sine x, then we choose u equal e power x and dv equal sine x dx. In this case, two periodic functions, we must reach the original integration by integration by parts 2 times. When we solve this example, we should do integration by parts 2 times to reach the original integration. If we start with integration for e power x sine x, we must reach it. For examples, We will take some examples on integration by parts. The first is sine minus 1x. Firstly, we should know that in case of inverse of trigonometric functions, we must use integration by parts. Sine minus 1 is the inverse, then we'll use integration by parts. We will put u by sine minus 1x, then du dx over root 1 minus x squared, dv by dx, then v equal x. We know the rule of integration by parts, that I equal uv minus integration v du. So integration uv it's equal x sine minus 1x minus integration v du equal integration for x dx over root 1 minus x squared. To solve this part, we're thinking about rational. Ln x here doesn't work, so we use reform. We can put it as 1 minus x squared power negative half dx. We're searching and do simple test for third key. D by dx for the function 1 minus x squared negative 2x. We will multiply it by negative 2 inside and the outside by negative half. So the integration, we will adding 1 to the power and dividing with the new power. We can cancel half. We can cancel half with another half. So the integration result will be x sine minus 1x plus square root 1 minus x squared plus c. The second example, integration x cube ln x. This function contains ln x. Then we use integration by parts. So ln x at all in u, then du equal dx over x, dv equal x cube dx, then v equal x power 4 over 4, and using the rule of integration by parts. Integration by parts, then uv equal 1 over 4 or x power 4 over 4 times ln x minus v du, then equal negative 1 over 4 x power 4 times dx over x times dx over x. The result will be integration for x cube, which is x power 4 over 4, and taking common factor x power 4 over 4, the result will be x power 4 times ln x minus 1 over 4 plus constant. Example 3, we have two functions, exponential function and x power 2. We not exact. The first key with the derivative of the power of a, then d by dx for x not equal x squared. So we will use integration by parts. Let we put x squared in u, then du equal to x dx, and dv equal e power x dx, so v equal e power x, and using the rule of integration by parts. uv, that's equal uv x squared e power x minus integration v du, it's equal negative 2 x integration for x e power x dx. We note that this integration x times e power x, also solving by integration by parts. Using integration by parts another time, let u equal x, then du equal dx, and dv equal e power x dx, so v equal e power x, and using the form of integration by parts, and we put it as I star. It's a sub-integration of the main integration we have. So it will be x e power x minus integration e power x dx. Integration for e power x equal e power x. We have the value of I star. We put it in relation 1, so the integration will be x squared e power x minus 2 integration x e power x minus e power x plus c. Example 4, we have integration for e power ax sine bx dx, product of two functions. Every function is a main function, so we use integration by parts. We will put u equal e power ax, then du equal ae power ax dx, and we put dv by sine bx dx, then v equal negative cosine bx over b, and we write the form of integration by parts, uv minus integration v du. Now we have negative 1 over b e power ax cosine bx plus a power a over b integration for a x cosine bx. We know this example we will reach the original integration e power ax sine bx, so we'll do integration by parts another time. Integration by parts another time for e power ax cosine bx. We put u by a power ax and du by a e power ax dx, so dv equal cosine bx dx and v sine bx over b, and use integration by parts, uv minus integration v du. So now we have 1 over b e power ax sine bx minus a over b integration e power ax sine bx. Integration e power ax sine bx, which is the main integration, we put it by I. Then the relation I star will be I star equal 1 over b e power ax sine bx minus a over b I. Let we put it in relation 1. So I equal negative 1 over b e power ax cosine bx plus a over b times the result of I star. Now to find it in the simplest form, it will equal negative 1 over b e power ax cosine bx plus a over b squared e power ax sine bx minus a squared over b squared I. This relation we can write it in the form I plus a squared over b squared I. We put it in the form of common denominator, then equal b squared plus a squared over b squared. Taking common denominator b squared in the right hand side, so we can cancel b squared by b squared and divided it the two sides by times it a squared plus b squared, which is in the left hand side, to find the value of I. We can reach that I equal e power ax over a squared plus b squared times brackets a sine bx minus b cosine bx plus constant. Now we can say that integration for e power ax times sine bx equal e power ax over a squared plus b squared brackets a sine bx minus b cosine bx plus constant. And also we can deduce that integration for e power ax cosine bx dx equal e power ax over a squared plus b squared times brackets a sine bx plus b cosine bx plus constant. That's all for section today. Thank you.